Let me tell you a little bit about myself. My name is Aurelio Garcia Ribeiro. I am a Senior Director of Product Management with Oracle. I've been with the JDK team for a very long time, since before the launch of JDK 7. So I've already reached the point where I can no longer blame my predecessors. All the supported versions, I had some of my fingers on it. One of the things that I do is I go through all of the JEPs and I try to write an explanation for them for internal Oracle teams and for other groups and other people. So I usually have a session like this for every section. This one being JDK 17 and LTS, I have on top of the usual list of features from the JEP, a couple of announcements that I expect most of you have already seen. So I'm going to go straight in. Let's see if this works. The first thing is we started release cadence of one new feature release every 6 months. So 2 releases per year, right? And Oracle said, we're going to offer long-term support, not to every release, because as you can imagine, if you extend all of these lines, there would be way too many releases to support. And that would mean way too many releases for everybody to choose from, right? So we said, we used to have a release every 3 years. That seemed to work. So let's have an LTS every 3 years. Now, after we did that, we've seen that the speed of adoption of the non-LTS releases is much faster. What do we mean with this? I used to keep track of when a new version of Java came out, when would IDEs or other common platforms start supporting that new version of Java? So for example, when JDK 8 came out, how long did it take for most IDEs to support Lambda, right? And after that, how long did it take for most common libraries to start accepting JDK 8? Now, perhaps due to the shorter time between releases, that time has shrunk significantly, right? Now, instead of having, when JDK 8 came out, it took several months before most IDEs supported all of the features. When JDK 11 came out, it was much shorter. Now, when JDK 17, most IDEs supported the features in 17 with the early access builds of 17. So even before 17 was out. And therefore, we think that we don't need to wait 3 years for a release. We can offer an LTS every 2 years. And this will have the benefit of making the non-LTS releases more attractive. And I didn't misspoke there. I actually mean that, because the point is, well, first, some developers that work in large enterprises, they told us, it's nice that you have these short-term releases, but we don't get to use them because our organization has mandated that we only use LTS releases. So we're stuck in the 3-year world. This 2-year cadence will allow them to get access to those features sooner. And the other thing that's important is, in the past, imagine that you adopted JDK 12, you needed to do 1, 2, 3, 4, 5 jumps before you get to a steady LTS. Now, worst case scenario, if you adopt 18, 1, 2, 3 jumps, and you're now in an LTS place. So we hope that this will make it so that more developers can get to those features sooner. So far, the proposal has received nothing but good reviews. So I'm pretty certain that this is what we're going to be doing. The other important change that we've done, and this is in regards to the Oracle JDK, is we used to offer JDK builds available to everybody at no cost, only for the tip of the spear. So in this graphic, we did it only for 11 until 12 came out, then 13, 14, and so on and so forth. And if we had gone according to that plan, JDK 17 would have released and be made available only until JDK 18. And after that, we were telling, if you want to continue getting updates for JDK 17, you'd have to become a customer and get a Java SE subscription. Now, what we've done is that, we heard loud and clear that you need the LTS to be available for longer. So we've proposed a change in the license. I think, did I get this color right? It's supposed to, yes, it's 1 year. Imagine that this perfectly aligns with this 22 down here. right? So what we're going to do is we're going to make JDK 17 available under a more permissive license. It's going to be free to use in production. And we will continue producing updates under this new license until 1 year of overlap with the next LTS. The goal being that if you want to go from LTS to LTS, you have 1 year to switch to the next LTS. If you want to continue using JDK 17 after that 1 year, then we're going to ask you if, to become a subscriber if you want to use it in production. So it's 1 year of overlap, given that we just said that we were proposing 2 years between LTS releases. That gives us a total of 3 years of updates to JDK 17 available to use in production at no cost, subject to the license terms, right? Now, that's it for the announcements of the release. Let's go for what's in JDK 17. Given that this is a Java user group, I expect that most of you are familiar with the term JEP, the Java enhancement, the JDK enhancement proposal, which is the unit of work that we've established for keeping track of the largest changes that go into each feature. JDK 14, it's fairly typical for the 6-month releases. It delivers 14 JEPs. We have a couple of language features, one of them in preview. We have some library improvements. We have some changes that will hopefully make it easier for developers' code written today to continue to work in later versions of the JDK. Now, evolving the platform also means deprecating and removing things, because if not, it gets too unwieldy to continue to maintain it. So we have 3 deprecations and removals. We introduce a new platform, and there's a change that I've labeled as for OpenJDK developers, because this is only, if you're using just the JDK binaries, there's no change from 16 to 17. But if you're looking at the source code in OpenJDK, there's that change. Remove an experimental AOT compiler. Now, when we show the JEPs, I always put the JEP number. All of what I'm going to say here is an extract of those JEPs. If you want to read into a lot more detail in the JEP, if you have questions that I did not cover, the easiest place to go is to the source of truth itself, the JEP, where you will find a much more detailed explanation of the change. And for those that need even more details, links to the aliases on which the whole feature was discussed. Some of these changes go back for many years, so you can go and read why something was done the way it was done. Let's go into the most fun to show, the Java language features. Whenever somebody brings a JDK presentation, this is what everybody wants to see, because those are the easiest to understand, right? They change how we write code. The one thing, though, is you only get the benefit of these features if you are writing new code, or if you are rewriting some old code and you get to take advantage of these, right? Later changes into the libraries and the JVM sometimes benefit people, even if they're just running in a code compiled in an older version. But here, let's take a look as to what's new here. JDK 17 adds to the standard sealed classes. And we've had a couple of previews of sealed classes on prior releases. With JDK 17, they're no longer considered a preview, so you can just use them. You don't need to pass a command flag to enable them at compile or at runtime. The idea of sealed classes is that sometimes we would like to know the complete set of classes that implement a particular interface, right? If we do that, we can make the code more concise. This works very nicely today, but it's also a step forward to simplify the changes that we're going to be doing with what's it called? The new, here, what does it say here? Project Amber and sorry, I'm blanking out. I'll get back to you when I remember the name of the project that that's going to take advantage of sealed classes. Here we go. Let's take a look, since it's source. The easiest way is to see some source code. So for example, we have a class and we convert it into a sealed class by adding this modifier, sealed. So now this class can only be extended by the classes or interfaces that are listed down here. So a class shape only can be extended by circle, rectangle, or square. Now, this class and all of the permitted subclasses have to be in the same module. If you're using a name module, they have to be in the same package, right? Every permitted subclass must directly extend the class up here. And every permitted subclass must choose a modifier to describe how it will continue the sealing. So here, let's take an example. You could say that a subclass is final, and therefore there can be no further subclassing. You could say that the subclass, in this case rectangle, is also sealed and permits its own set of permitted subclasses. Or it could be non-sealed. You have to specify it, and you can say, okay, this square in here, in this case, that's not sealed. That one could be extended. As long as the class is of type square, you know, the subclass shape will know it's a type here. So you cannot prevent one of the subclasses from, if you will, continuing the non-sealed part. Okay. Now, if you're using reflection to try to determine if a class is sealed, we've added two new methods. So now you can query a class and you can determine if the class or the interface is sealed. And if it is sealed, you can query another method to get a complete list of the permitted subclasses. Okay. The other one, the other language feature in JDK 17 is pattern matching for switch. Now, important to note the preview marker here. Preview means that this feature is fully specified and it's implemented. And this is not a beta, but it is still impermanent. We are asking for feedback, and we expect to hear from the community that will tell us, oh, here's how you can tweak it to make it slightly better. In other words, if you're using pattern matching for switch, it might change slightly in future versions of Java. And therefore, in order to use it, you need to tell the compiler that you're okay with preview features. And it's not just the compiler, because one of the points of preview features is, I don't want somebody to go and write some sort of library, compile it saying preview features are okay, pass it on to a developer who uses the library without knowing that it depends on a preview feature. So preview features need to also be enabled at runtime, not just at compile time. That way, nobody can sneak a preview feature to you. If you get a library that requires preview features, be wary. You know you're not going to be able to use it. You know, possibly you won't be able to use it as is in a future version of the JDK. So what's the idea of pattern matching for switch? It will allow an expression to be tested against a number of patterns, and each one have a specific action. The idea now is, instead of just having the case labels be constant or enums, we're going to be able to put a complete pattern. And we introduce a case null statement. Again, example. Here's, if you want to work on a type and say, okay, here's an object, and I don't know what type it is. I'm going to test for a bunch of types. Well, if it's an integer, then, you know, return this value. If it's a long, treat it this other way. If it's a double, or if it's a string, right? Return formatted. Using pattern matching in a switch, we can make this much easier to read, right? And as a bonus point, this code is optimizable by the compiler. So we still have the, if you're using a switch, the case list must be exhaustive. So normally, unless you're running, you're writing all possible values, you will want a default value. Okay. Now, there's one thing that's missing here. Traditionally, switch statements and switch expressions throw a null pointer exception if the value that I put in here evaluates to null. So normally you would have a first check, see if the object is null, if not return, and then do the switch. Now we figure, this is what it would normally look like, right? You would test outside of the null of the switch statement. But since we are going to make the labels a lot more complex to allow for type patterns, might as well allow for a case null and include it in the switch statement. Now, another common thing to do was, okay, if it's a string, then I have to do some other further test. And that creates code that it's a little hard to read. You can improve the readability of this code with something that we call guarded patterns, which is a combination of pattern matching and Boolean expression. So instead of writing this case string and then an if down here, we put both of them in the case statement. Case the string and the length equals 0, then do something. All other strings go to the next one. Okay, so I thought this was nice. Pattern matching for switch, as I've just described, introduces a couple of new errors that we didn't see before. So the first one is that a pattern could dominate a later pattern, right? So if a pattern in a switch block is dominated by an early pattern, that is a compile time error. So in this is the same example that I had before, but I've changed the order, right? What does it mean to be dominated? The first case would cover all strings, including the ones of length 1. So the second case would never be reached. It is dominated by the prior one. If you try to do this, you'll get an error. Okay. The second one is there is no fall through allowed when declaring a pattern variable. In switch statements, you can have a break, or you can just continue with fall through. But let's imagine, well, there you go for clicking on the wrong one here. Let's imagine that we have this switch statement, right? There is no break here. So imagine that the variable O was of type character. It would go over here and say, okay, it's a type character. Let's do a print line character. Then, since there is no break statement, if it falls through, the variable I has not been initialized. So this would not work, right? You can fall through types that don't declare a pattern, but the ones that declare a pattern, you have to break out, right? Either yield or break out. So those are the two new special cases. Now that's it for the language features. JDK 17 also improves on the libraries. Some of you may use these APIs directly. Others may just benefit when somebody else takes on, creates a new library that uses these improvements. So we've refactored the pseudo random number generators. Perhaps it's a little bit too much detail, but the code in OpenJDK that produced these classes was a bit messy, and that's been cleaned up. As part of that cleanup, we've introduced, you used to have several pseudo random number generation classes to choose from, but there was no common interface. Now we've introduced interfaces like random generator, which all of the existing PRNG classes now implement. And therefore, it will be easier to change them if your needs change without having to rewrite the whole code. right? Another point is when you're using a random number generator, the algorithms used for generating random numbers change relatively frequently. So it's a bad idea if your code were to call for a particular algorithm, because for all you know, that one will be obsolete in a couple of years. And then your code, if it asked for that algorithm, when that algorithm gets removed, will break. So rather than asking for, give me a pseudo random number generator by algorithm, you can say, here's the characteristics of the algorithm that I want. For example, I need it to be jumpable, right? And I want to have one that has a particular number of characters of entropy, right? Or state bits. And then just say, from the list of algorithms that you have, find one that has that characteristics and use that one. If you write it that way, then as long as there's a new algorithm that provides those capabilities, your code will continue to work into the future. In order to do that, we have now a random generator factory, right? That will give you a stream of all the available algorithms. Then you say filter on jumpable and filter further on state bits greater than X and get any. Okay. There is a couple of two new algorithms, Soshido 256++ and Soshido 128++. And if you were, I'm not going to try to explain what they are. If you were waiting for them, you probably know more about this than I do. Another JEP that's quite interesting, as most of us know, the new Mac computers are now running. I'm sorry, this is the new rendering pipeline. I'm ahead of myself. So Apple used a rendering pipeline that, I'm sorry, I'm gonna step back. The JDK for Apple relied on OpenGL APIs, which were the standard on Mac OS. Now, Mac OS, Apple has already said, we're going to deprecate OpenGL API. And here's a new API, Metal API, that you should be using instead. Okay. Java 2D needed the OpenGL APIs, which is still shipped with the Mac. And it has a fallback, which is software implementation, so it's much slower. What we wanted to do was create a new rendering pipeline and have it available on Macs, so that if at some point Apple removes their support for OpenGL APIs, there is another hardware, a proper rendering pipeline. Now, for compatibility, this new rendering pipeline is disabled by default. If you are running on a Mac, we'd like to ask you to turn it on and please report any issues. It should work right off the bat, but there may be some edge cases. Let us know, and hopefully when we get enough feedback, we can flip it on by default. And even if we don't, right now, if Apple were to announce that the next version of their operating system will no longer ship with OpenGL, then the current version of 17 will be able to fall back on this one. Okay. Context-specific deserialization filters. So I think it was in JDK 9 that we introduced deserialization filters. You could tell your Java runtime, here is a set of classes that you can serialize, or here's some classes that you cannot, that you can deserialize, or here's some that you can not deserialize. And then there was a JDK-wide set of filters that would allow somebody to say, I only want you to deserialize the following classes, right? And create an allow list of classes. Now, that works pretty well, but it's very difficult to use when, for example, you're relying on third-party libraries, or you want to modify the code. You don't want to have to change the serialization filters for the whole JDK. With this enhancement, we allow you to create, we now offer a JVM-wide filter factory. So you can say, okay, here's the filter factory. This will allow you to say, when my, when my stream is trying to deserialize something, give it this filter. When your stream is trying to deserialize something, give it this other filter. So now you can create custom filters per stream. And this makes it significantly easier to use. This is one of those very few features that is already being backported to earlier versions. So serialization filtering was backported from 9 to 8. This improvement in the context-specific deserialization filters will also be backported, at least for Oracle, all the way to JDK 8. And we get a couple of APIs in Incubator module, courtesy of Project Panama. Check at the time, we're still good. Incubator is morally equivalent to Preview. The difference is that we can use incubators for APIs, because we can say, okay, this API goes into this Incubator module, and therefore if you don't bring in the Incubator module, you don't get it. We need previews for language features or for changes in the JVM, but same idea, right? Incubator modules are not on by default. If you want to try this, you'll have to download, you'll have to enable them. But these foreign functions are the result of the work done in Project Panama. And the goal of them is to make it trivial for Java developers to use any native library. The what was it? The statically typed pure Java access to native code will make, well, will in this case is for C code specifically, right? Will save us from having to develop and maintain multiple artifacts. Right now, if you want to use C on Java, you have to maintain a Java API, a C header file, and the C implementations. And this you have to do for each supported platform, because it's not cross-platforms. Now you're talking to C. So you may need different tools for each platform. It gets very complicated. By adding these APIs, we try to make it simpler. Another incubated API is the ability to write code that will use vector instructions. Okay, so the JVM supports auto-vectorization, but it relies on some known patterns to identify what it can convert to vector operations and what not. And if we were to give developers the option of saying, okay, JVM, nice try, but you're not getting it. Here's some operation that I know is meant to run directly as a vector. These will yield more consistent results. Okay, so for those of you that are not familiar, there is a very simplified conceptual example, right? If you have a set of operations that you're going to do on a group of values, rather than doing it sequentially, you may be able to load those values into a vector and execute the operation on the complete set. So before we had for multiplications, for additions, and for assignments. After you get one multiplication, one addition, one assignment with vector operations. Now, these types of operations are very common in machine learning and in cryptography. Truth be told, I expect most developers will never use this API directly. What I expect will happen is people will write libraries for accessing, for doing machine learning that will implement this. And then we will all get the benefit of those libraries' improved performance without having to actually write any vector instructions ourselves. Now, here's the part that people will say, this is the one that's going to break you. We're going to strongly encapsulate JDK internals by default. This started with JDK 9, right, with the introductions of modules. step back. I take it I take it as a given that we all know what internal APIs are, but just in case, the JDK has a bunch of standard APIs. Some are part of the Java specification, and you cannot call yourself Java if you don't implement those. Others are not part of the specification. They're part of just an implementation, but they are officially supported, and we are documenting them, and we're saying, go ahead and use them. And then there's some other APIs that are meant to be used by the developers of the JDK to provide the supported implementation. And developers were never supposed to use those APIs because they're subject to change, right? If we think of something better, we can change them, we stop using them, et cetera, et cetera. Of course, if the source code to those APIs is available, people find them, start using them. And then when JDK 9 came out, once we had modules, we could have decided by default, all of the internal APIs are going to be closed and they're not going to work. But if we had done that, we went and we looked at open source repositories, and we noticed that most frameworks used some of the internal APIs. So we said changing them without notice would break way too many things. So the compromise was, okay, we are going to eventually close them, but we need some cool down period. So between JDK 9 and JDK 15, if you were using internal APIs, you would get a warning, but you would still be able to get them. In JDK 16, the default is now illegal access, but you could, with a single command line option, revert back to the previous functionality. With JDK 17, you can no longer, with a single command line option, open up all of the internals. If you still need them, and please tell me that it's only temporary and you're working to stop those needs, you will have to turn them on one at a time, right? You will have to say exactly which, this add opens command line option or the add opens jar file manifest attribute. You will be able to open specific packages. Now, this is it, by the way. This is the last change. We don't expect to do any further changes. This doesn't mean that if you hard code add opens command, you're good, because what may change is the underlying internal API. Now that less people are using it, we're more likely to be willing to change those internal APIs. So this is the last warning. There's still a way around it if you have not figured out how to use those internal APIs. And there's an important detail here, except for critical internal APIs. So there's a list of a few APIs, such as sun, misc, and save. Well, I wasn't trying to click here. I was trying to admit somebody. Sorry. There's a few critical internal APIs that continue to be enabled by default. Okay, these are the ones that were continuing to work before. Until we have replacements and have some time for people to move away from them, we will continue to make those available. Next one. Restore always strict floating point semantics. I have to confess that when I read this one, I had to go and figure out exactly what does this mean. There is a fantastic session by Joe Darcy that explains some of the issues about floating point semantics and why you have to have some, why when you add floating point numbers or you multiply them, you don't actually get mathematically exact results. Okay, fascinating. Go take a look at it. The point, though, was Java 1.2 back in the days introduced a floating point semantics that was a bit more relaxed than before. And the reason was that early x86 systems had a bad interaction with some of the JVM semantics. And in order to be precise, you had to do a lot more operations. Now, if you were not going to have overflow and underflow, you could do it much more efficiently if we relaxed the floating point semantics. So there was the optional of not having always be strict. And we did that in Java 1.2. Now, around 2001, processors started coming up with new extensions that made it possible to use the more strict floating point semantics without this additional overhead. So now we're going back to saying, okay, these more, the less strict one that was only optional, it wasn't required, not every platform allowed it. Yeah, that's no longer in it. We expect that this will not affect any existing applications because, as I said, most strict execution was always an option. And if you really want to understand this, the Joe Darcy, I'll probably send the link at the end. The Joe Darcy Java Developer Live session on strict floating point semantics is what you want to see. Now, deprecations and removal. Some short-term pain in exchange for long-term ability to maintain the platform. We wouldn't be able to continue updating and progressing the platform at a reasonable pace without this. What do we have? We already had the applet API marked as deprecated since JDK 9. What we're doing with JDK 17 is we're going to tag it as deprecated for removal, which means in the unlikely case that you were still using it, you will now get additional warnings. Okay. The second entry here is the security manager. It's been available since JDK 1, and it was used to create the Java sandbox. So when we run untrusted applets, the security manager handled it. Now, in theory, it could have helped protect server-side code, but in the real world, it was very rarely used for this purpose. Because in order to use it for that, it needed developers to adopt a permission model, very brittle, and it was difficult to understand and maintain. And it imposed some significant performance penalty. All of that resulted in very low adoption for securing applications. And many of those not coded correctly, so they don't actually provide the security that developers thought they were going to get. Now, the cost of maintaining the security manager is quite high because it is tightly woven into every class library. And that means that if we try to maintain it as is, it produces this unacceptable tax on all future development of the platform. Okay. Now, even though it was not used for security, there are a few use cases for which it has been widely adopted. For example, a few frameworks use it to keep managed code from calling system exit, right? Or they want to be able to monitor whether an application opens connections to some ports and some files. Now, those use cases can be addressed with much, much cheaper alternatives. The goal of deprecating the security manager is to help us identify if there are any other such use cases that we may have missed. And that way we will have, once we identify them, we're working on those alternatives, especially for the system exit, right? And we'd like to have a complete set. Once we believe we've had a complete set of valid use cases and we have alternatives, at that point, we will propose to remove the security manager from the platform. Okay. Mind you, having it removed in some future version, it's not retroactive. So even if it were removed before the next LTS, I don't think so, but possible, you can continue using the security manager in JDK 17 at least until 2029. The other thing is we no longer include RMI activation. It was deprecated for removal in JDK 15. Now, don't freak out if you use RMI. This is just RMI activation. And that's it for the features. Now let's look at the platforms. Well, it's also a JEP. macOS Arch 64 port. As I was jumping the gun before, the new Apple computers are running on ARM. And even though it was possible to run the x64 builds on ARMs, using, what was it, Rosetta or Rosetta 2, yes. The translation, it didn't work as nicely as it could have been. So now we have it in native ARM64. Finally, I said some of the changes are not visible if you download the binaries. They're easier only if you're looking at OpenJDK work. So we introduced an experimental feature in JDK 9, an ahead-of-time compiler and a JIT compiler. They saw very little adoption, and the cost of maintaining them was pretty high. Now, since the features were optional, they were already excluded from Oracle's builds of JDK 16. That's why it's meant that if you were going from 16 to 17, you don't see a change here. JDK 17 removes the source code from OpenJDK. So, if you will, it finalizes this. Right. Note that the part of the work to add the experimental JIT was to include an experimental JVM compiler interface. We're removing the experimental JIT, but we're keeping the interface that will allow externally built versions of the JIT compiler, right? So that part remains there. Now, release details. Where do you get JDK 17? If you want the Oracle JDK binaries, which we'll continue to provide updates for under the current terms for 3 years in total, oracle.com Java download. And if you want the open JDK binaries from Oracle, jdk.java.net. Also in jdk.java.net is already previews of JDK 18 and some early access builds for from other projects that we're working on. So go take a look at that one. The list of supported platforms is what you will expect. Now, I'm jumping the gun here. This list, if you compare this to the list of JDK 17 certified system configurations currently listed, we need to update. We've added a few things. So we've added Ubuntu 21.10 and Windows Server 2022 and Windows 11. We've added those with the October CPU. So those were what we currently have in the website is the list from the GA version. Didn't include those. They hadn't released then. They have released now. And other than that is the rev of what you would expect. Oracle Linux, Red Hat Linux, Ubuntu, SUSE. We have Linux on ARM64, Windows on x64, and macOS, as we just said, in x64 are on ARM64. I always get a question, does it mean that it doesn't work on any other platform? No. The certified system configurations is what we have tested on. We know it works in a bunch of other flavors of Linux, right? If you go and try it on Asia Linux or in CentOS, it'll probably work. What this means is if you're a support customer and you file a bug and you say, hey, I'm using CentOS, we'll tell you, that's great. The closest one that we have for CentOS is Oracle Linux. We will debug and try to produce a fix on Oracle Linux. And when we're done, we hope it fixes also on CentOS. We will not ask you to reproduce in one of these, but likewise, we may not be able to reproduce it in your chosen platform if it's not on this list. Okay, see a chat here. Finally, this was, as long as it may have seen, this is just a little bit of a preview. If you go into the OpenJDK page and you click in any one of these JEPs, you will see about the same length of this whole presentation, but on any one of those JEPs. So that's it. Thank you. With that, I'm going to turn off my presentation and see if we have any questions or comments. Oh, actually, let me throw in one more thing.
Please.
Here. I'm particularly proud of this one because I was fighting for these for a while. One of the side effects of having this new license is that you no longer need to click on a license to download it, right? So this is the main download page. This is the, I showed a funny URL, oracle.com Java download. It expands to this, right? These are the JDK 17 links. the bottom ones, 11 and 8, they continue to have a, you click on here, you need to accept the license, right? And you need to click on here. So that means you cannot really have a script that will grab them for you. With 17, we don't have the problem. You click on this thing, you start at it. This URL will remain exactly like it is for the 3 years that Java 17 will be made available. Notice that it says JDK 17. Right now, it gets you 1701. When 1702 comes out, you will click on this same URL, you will get 1702, and so on and so forth. The idea is, and here's, what I'm saying is called out here. You can automate it. You can wget this, and you will get the last version of JDK 17, right? Or you can curl it. If you are the kind of person that actually checks checksums, all you have to do is add a SHA-256 at the end, and you will get the checksum for said release in a format. This is not HTML for you to parse. This is just read it. If you are lazy like me and you just want to see, well, how does it actually look? Here's a portion of a Docker file. This Docker build will build an image that will curl the latest version of Java and will update it. So this code right here will get the version of 17 from here until 3 years from now. Now, if for some particular reason you don't want the latest version, you want a particular version, you can get the archive. Notice that these say latest, and the URL is always 17. If you look at the archive for 17, if you say archive and give it the full number, this URL will get you the exact version. So if today you use latest, you get 1701. If for some reason you wanted to download the original GA version, here's how you will get it. Okay. So I know it's silly, but hey, been waiting to do this for a while. It certainly keeps my life easier. I don't have to update a Docker file with every release now for 17. I still need to do it for 11 and 8.
Lots of people use Puppet, Chef, Terraform, Ansible, right? So this is really helpful to just be able to script it or shell, bash scripts. Geez, anything.
Yep, don't write these down. But we're also planning on providing some sort of JSON file that will list all of these API, so that you can programmatically find them. For now, I presume you'll only want one or perhaps two or whatever, right? So, and as I said, here's the script-friendly part. Keep in mind the availability. The latest ones will work for as long as there is an up-to-date version of JDK 17. So expect them to stop working after September 2024. The archive ones will continue to work, right? But we don't want to misinform you. We don't want you to be trying this when there's no more versions available there. So that's why we will disable the latest at some point. We expect to do the same for 18, 19, and so on and so forth.
Awesome. Aurelio, did you already cover what the next LTS release is planned to be in the future? Or I might have missed it.
Yes, that was at the beginning. I pointed out that the next LTS was going to be 3 years away. Now it's planned to be 2 years away. So it's supposed to be JDK 21 in, for anybody that does math, 2023.
Awesome. Folks, this is a great time to hit up your questions in the chat. We can also, how many people are we? Let's see. We could, Courtney, we could potentially unmute folks. Why don't we unmute everyone and let them mute themselves if they want to jump in and ask questions?
My suggestion, don't bulk unmute. I've done this before, and then you'll hear everybody's dogs and kids and everything. You just let everybody that wants to ask a question unmute themselves. I made that mistake before.
Right.
I left everyone. I gave everyone sorry, I can't turn on my camera, but I gave everyone, there we go, the ability to unmute themselves today after last week. So everyone should be able to unmute themselves, just maybe give a little hide so not everyone starts at once. Right. But everyone should remain muted unless you unmute yourself.
Yeah, feel free to unmute yourself and turn on your camera if you want to, like pretend that we're now in the hallway track of the event.
Nice. Where's the office, Aurelio? This is quite a nice backdrop.
This is like here.
Yeah, I figured. I know.
Yeah.
I was teasing.
Yeah, it's the office I want to have.
Well, super awesome that you spent some time with us tonight. And again, folks, sorry for coming in a bit late. If you do want to access a recording of the video, Courtney probably already mentioned to you that it is available on our YouTube channel. So if you want, subscribe to the YouTube channel so you get a notice. We try to remember to send it out to the San Francisco Jug email list, but frequently forget. So the best thing to do would be to subscribe to YouTube for the moment. And if you want to get a talk recording that you can share with your colleagues.
I do see a question about the OCP for JDK 17. I hope you mean the Oracle Certified Professional, the training class. I have to confess that I had to look it up to make sure. If that's what you're asking for, I'm not part of Oracle University. I'm sure that they're working with some upgraded course. I expect it would come out shortly.
Cool.
Right, but yeah, I'd have to direct you to the website. You'll find it as easy as I will.
Awesome. Cool. Yeah. Anyone else with questions? And then how do you find? I don't know if you might have gone over this already, but how are you finding adoption of the LTS releases? Are people upgrading, or is everyone still just being conservative and sticking to Java 8? And holding on for dear life.
Well. That's it's not necessarily 17. You can also be looking at 11.
No doubt.
Right. So here's the point, right? People expect me to be like, oh, you should move everything to JDK 17 today because we've just released JDK 7. That's unrealistic, right? A version of the JDK comes out. If you wrote all of the code in your application and you don't use any third-party libraries, then yeah, you could probably move to JDK 17 today, right? But if you rely on some third-party libraries, then the long pole is going to be, oh, I need to wait for the libraries that I use to be available on 17. And those libraries themselves sometimes have a requirement. It gets even worse if you're not using just libraries, but say some framework. So we expect the adoption to be, slower at the beginning. And we expect that it's not like a company goes from 8 to 11 to 17. It's like some projects in the same company will be on 8, others will be in 11, and hopefully the new stuff is being coded on 17. Okay, so with the caveat, we've seen some really nice download numbers for 17. I jokingly take credit because I said, oh, it's my automatic download thing. That's what triggered everything. Yes, that's it. That's why everybody's getting it. It may be the LTS or the new, I don't know what it is. But yeah, we've seen a pretty decent adoption of 17 so far. We hope that it continues. We'll start seeing it when we start to see it in production. That's the interesting part.
All right, Aurelio, you're going to be shocked that I'm asking you this question, but it's just been a long day and I'm a little tired. So I think I know this somewhere in the back of my head, but I've just forgotten. Can you get them via Maven and Gradle? Can you get these releases via Maven and Gradle, or am I going nuts and it's not available in the Maven Central?
Let me answer the question that I prefer, which is we do not post them on Maven and Gradle.
Got it. Okay.
Okay.
Other people
we have them here.
Post them to their own internal repositories all day long. Yeah. Okay.
Yeah. I mean, we do have, in case you wanted, Oracle offers something called Oracle Container Registry. Mm-hmm. There's some images. There's some OCI compliant images.
Oh, nice.
Oracle. Oh, you didn't know that one?
Yeah, sweet. Okay, so you can get certified Docker images. Sweet. Okay, that's nice.
Oracle.
I figured that was there.
Registry.
Yeah. Cool.
And there you go.
Yeah.
Registry. I mean, unfortunately, I don't have a fancy URL to show, but here you go, Java.
That works. Yeah, no, it's totally
JDK
there.
17. Yeah. Now, since this is an Oracle thing, you have to sign in, right? Yep. And then you'll be able to Docker login container registry, and then your Docker pull will work. Right now, you can get latest will get you 17. You can get 17 on Oracle Linux. You can get 16, 1602, 16. We switched. We used to have 11, went all the way to Oracle Linux 7. But you have the latest if you have 11.0. Why is it 11.0.13 out here? I'll have to go and take a look. But
Aurelio, one other question coming in from chat about the tutorial docs. If you can see it, he was curious if the tutorial docs were going to be upgraded. He was linking to the canonical Java SE tutorial.
The tutorial is going to be upgraded anytime soon. Okay, so here's the thing, right? We wish we could just like with every release rewrite everything, but we have a long list of changes. So punctual changes to the tutorials will happen. A bulk, let's just rewrite everything with every release, would be a tremendous amount of effort and would have to be done so frequently that we figured, okay, if we wait for that to happen, we may not, we may take them down. So when there's something that it's now very much wrong, we go and update them. But a wholesale update so that everything is now in 17, and then another one with 18 next March. Yeah, that's probably not in the near future.
Got it. Okay, so you're kind of working that behind the release train. Yeah, that makes sense.
Yes.
The mass documentation base. I just want to say that so the folks on the here in San Francisco Java user group, they see me most weeks, that we have a meetup, and they know that I work at DataStax, and we're one of the majority sponsors and committers behind Apache Cassandra. And let me tell you, the zero GC stuff, and I know this is not new to Java 17, but it's gotten better from what I understand in Java 17. And
let me correct you though, ZGC, not zero.
Excuse me, Z. Check.
ZGC.
Thank you, sir. If you traverse that link that I just dropped in the chat, I mean, we were finding just gigantic, performance improvements, as a result, particularly in certain like key value, lookup kind of, get put sort of use cases, and just fantastic. I mean, it's like such a great benefit. I know you said that, sometimes it's unrealistic, right, for people to have to step up to different JDKs and versions and upgrade, but it's like the benefits are just so there in this particular case, like for us. So, for folks that can try to stay current, it makes there's lots of little pots.
Yes, that's my point, right? When we look at what's coming out on every release, I see it as we have a pie, right? We have language features. That's candy for developers to get them to adopt the new version. But there is what I call, like the silent benefit, which is there's improvements in the libraries and the JVMs, which means that code that was written on, older versions, if you just grab something that was compiled on Java 11 and run it on 17, you will see it uses less memory. It performs better.
Scroll down a little bit to where it says ZGC performance results, and you'll see a graph. It's a little farther down.
Yeah.
There you go. Like, check that out. There it is. Cassandra 3.11 is in blue, Cassandra 4.0 in red, and I think it was like a subsequent release candidate that I'm not sure whether that actually made the basis of GA or not, the beta 4. But I mean, and again, like for us, this was just literally we're just changing the JVM and the JRE, right? I mean, like this is free,
that's my point. There's
money,
a lot of goodness by applying a new version. Okay, a couple of other
total free money.
Yeah. Here's a couple of new things, by the way. The new APIs here, when you look at new or deprecated, you can now filter by when was it added. So if you want to see the new packages, this is here. What was added in 17? What was added in 14? What was added in 12?
Ooh, that's nice.
New interfaces in 16 or in 17 or in total, right? Since this is from 11 onwards. So
very cool. Yeah,
this is nice. And let me throw my last Java.com releases. This backstory behind this is there was some people say, well, Java.com, if you need to be able to spell. There was somebody that, in Java.com that said, like, oh, let's not have the Java version history in Wikipedia and stuff like that. And we're like, well, let's provide a canonical place to go for it. Here's a list of all of the releases, including the planned ones. So here's the new ones that still not GA. All the released ones with the release date, the version, right? Java.com releases, pretty straightforward. All the way to, right, 1985, the first one. Damn. Information that the name, the binaries, but this is cute, but here's the one I like, view by month. There you go.
Sure.
So this is what it's currently, these are the current releases, like when you say, what should you be running? People say update versus upgrade. This is, a nice page to
this
have.
would be a nightmare web page on Wikipedia. Good call. Putting it on the Oracle site. I agree.
Yeah.
This would sort of be a bit of a mess to look at on Wikipedia for sure.
Right. So now we have now I use this page all the time where people ask me, like, hey, when did we release some version and what should I update to? And when is the next version coming out? There.
And I'm curious to hear what people think in the audience. What's been your experience with the long tail that Aurelio mentions? The libraries, like, because I see Spring, and you all from San Francisco Java user group, probably remember for the 7+ years I was on the Spring team, and they plan sometimes for their releases to hit like the day of the JDK release, like they're working with the pre-release versions. So Hibernate, Spring, there's a lot of libraries I think out there that do a really good job. Raphael with Byte Buddy, right? Aurelio,
Raphael, he's amazing. Remember I told you I was keeping track?
Yep.
I had to double check 3 or 4 times. That guy's like, no, it cannot be. He cannot be that quick. I had to go and look. I know he is. He's.
Yeah,
and
no,
given that
a lot of the ecosystem picks it up. It's really nice to see. So I'm curious, folks, what libraries are you using out there that you're excited to see pick up JDK 17, or maybe if they haven't even made it there yet, or an earlier version? We'd love to hear from you. And yeah, just shout out in the chat or unmute yourself. Talk a little bit about what you're using. I'm sure Aurelio would be very interested, and this is a great chance to give him your feedback, like direct to the horse's. It's the horse's mouth. Yes.
Yeah, sure.
That end of the horse.
I got you.
Yeah, that end. But if y'all are feeling shy and don't want to speak, understood. No problem. Just want to try to get your feedback. So, oh, sweet. Yeah. Pierre. Yeah. Monet says move to 1.17. Cool. Excellent.
Okay.
Yeah. Someone else.
There's no 1 dot anymore. We dropped the 1 dot with 9, so
right,
it should be 11 going to 17. True.
Well, then we had On today before saying that he just migrated one of his production platforms to 17 this week. The French guy. Exactly. Je suis désolé, Pierre. Sorry. So yeah, I think that the currencies was certainly really helpful for Cassandra community, and I think I've been impressed with the libraries I've seen how quickly they pick it up. So I think they're excited, to check out the new features. And geez, anyone that is using Java to create some sort of a server process or managed state or anything even remotely long running, they're going to really appreciate all this EGC improvements. Like, it's just.
Yeah. So I don't know, M. Gitman. Yeah, I hear you about that. Like the previews to me are a little annoying too, because I see good. You don't know how disappointed I was when what was it? Text blocks wasn't included in the I think it was going to be in 11, and then it ended up getting kicked to 12, and I was so disappointed, right? And now an interesting exercise is to look at how the preview features evolve, and you will see that there are very minor changes between the preview. We've pretty much established a cadence that most of them do 1 preview, 2nd preview, then go into the standard. Right? And if you look at the delta between those previews, it's very small. So if you were using the preview feature, adapting your code to the final one was trivial. But it's usually gold, right? Those little changes are what make the difference between something that just feels supernatural. So I am now a convert, and I'll defend the premise that, yeah, I know it's annoying to have something in preview for a couple of releases, right? But the benefits are so big. And now that I look back, that it arrived in 12 versus 14, who cares? It's already there now, and it's well done. So I'll continue saying I am now a convert. Go preview features.